we have one last example to where we're going to go through and take a look at all the different aspects of least squares lines. So we're going to learn how to identify the response as well as the explanatory variable. We're going to learn how to go through and compute the least squares line and then to check it in the calculator. We're also going to go through and do an extrapolation or interpolation, and then also to be able to define whether it's interpolation or extrapolation. Then we're going to go through, compute the residuals, construct the residual plot, and identify outliers. So we have some data where we only have 4 NFL quarterbacks, and it shows their height and weight of the 4 quarterbacks. So we know that there's many more quarterbacks, but just for simplicity, we only want to use 4 as opposed to maybe 30 or 40 or something like that, where the monotonous computations would drag down the time to be able to learn this. So we're going to start by defining the explanatory and the response variable, right? And that's pretty easy because it looks like that the height is going to explain the weight. So the explanatory variable is going to be the height, and the response variable is going to be the weight. All right, so we're going to predict the height based on the weight. We're going to draw a scatter plot, making sure the data is linear. If it's not linear, then we can't do the problem. All right, so here's our graph, our scatter plot. Our range of values for the explanatory variable are from 71 to 77. So we could probably just go in increments of 1. Okay, and that's our heights. And the heights are in inches. And then we have our weights, which range, I believe, from 206 to 244. All right, so let's start at 200 and go up to 250 in increments of 10. So 200, 210, 220, 230, 240, and 250. All right, and these are weights. And those are in pounds. All right, so our data, we have 77,244. So that's going to be all the way over here, and we have our scatter plot that ends up right here. And then we have 71,206, so maybe right about here. And then we have 76,225, right? So maybe right about here. Again, tough to do on the screen, so forgive me if it's not exact. And then finally, 75,214, that's going to be maybe right about here. All right, so the data doesn't necessarily look completely linear, but it looks decently linear. Okay, so like if I was to draw a line through this, all right, maybe something like that, it wouldn't be awful. Okay, so that's what we're looking at. And now, of course, with the scatter plot, we never want to draw a line through it. Okay, we're just going to keep it with just the dots there. All right, so it looks like we're linear, it looks like we're good. So now we're going to move on to part C. Part C says compute the equation of the least squares line, and we're going to have to find all of these variables in the calculator. All right, so we're going to bring up our calculator, we're going to hit stat, and then we're going to hit enter for edit. Remember, if there's anything in the list, if you want to clear it out, you just go up to the title of the list, hit clear. Don't hit delete, but hit clear, and then enter. And remember, our data for the X, the heights, was 77 inches, 71 inches, 76 inches, 75 inches. And the weights, the Y variable, was 244, and 206, 225, and then finally 214. All right. And remember, to get SX, XY, X bar, and Y bar, you're going to hit stat. You're going to go over to calc. And you're just going to go down to 2 var stats, and you're going to hit enter a few times. All right, and there we are. So this is our X bar, our SX, we have our Y bar, and our SY is just hidden a little bit, so you have to click down. Anytime you have this down arrow, remember that there's more data kind of lingering there. All right, and so let me just make sure I copy these down correctly. 7475, 2.630, good. 225.25 and 1646. Good. All right, so we're going to go back and I'm just going to copy these down. All right, so for part C, we have X bar, which is 74.25 or 74.75, excuse me. And we have SX, which is approximately 2.630. And we have Y bar, which is 225.25. And then we have SY, which is approximately 1646. Right? And then the very last thing that we have to do is we have to get R, right? Now R, we're going to have to go into the calculator and do just a little bit different command, right? So to get R, we're going to hit stat, and we're going to go over to calc again. And instead of going to 2var stats, remember you go to linreg ax plus b. And we'll hit enter a few times. Right. And so the R value is 0.8567. Right? So R in this case is approximately 0.8567. All right. And remember, that means it's a strong positive association, which is evident from the scatter plot. It's a pretty linear, strong association, and it's positive. We can't tell it's linear from R, but we can certainly tell that it's positive and it's strong. All right. So based on that, now we can compute the least squares line. And remember, this is the formula. And remember, B sub 1 is equal to R SY over SX. And then B sub naught is equal to Y bar minus the quantity of B sub 1 times X bar. And we can substitute those back in. Okay? So for B sub 1, which we need first to get to B sub naught, that's going to be 0.8567, which was R. And then we're just going to type in SY and SX, or right in there. So 1646 divided by 2.63. Right? And let's just type that into our calculator. So we had 0.8567. We're going to multiply that by, we said 1646, which was SY. And then we're going to divide that by 2.63, I believe. Right. And that leaves us with 5.362 approximately. That's 5.362. Now we need B naught, and B naught is going to be equal to Y bar, which we found to be 225.25 minus B sub 1, 5.362, which we just got. Okay, and I'm just using this formula right now. Okay, and then we're going to multiply that by X or S bar, which is 74.75. Okay, so we're going to hold on to this number because we need it, and then we're going to go ahead and we're going to get our B naught. So let's plug that into our calculator. So it's 225.25 minus the quantity of 5.362 times 74.75. Right? And we just hit enter, and we get negative 175.55. All right, or 175.56 if you wanted to round it to 2 decimal places. So that's going to be our B naught. So 175, and I forgot the number already, 56. Now, here's a way to check to make sure that your numbers are at least close. Right? What you can do is you can go into stat and then go back to linreg ax plus b. Hit enter, enter a few more times. Okay. And notice the numbers for A and B. So A is 5.361. And remember we got for B1. For B1, we got 5.362. So that's really close. All right. And then for our X bar, or I'm sorry, for our B naught, it looks like that the calculator says negative 178.51, all right? And we got negative 175.56 It might have been due to a rounding error or something like that. Let me compute it again just one more time, just to make sure I didn't make any mistakes. So 225.25 minus, and we had 5.362, I think. Let me check really quickly. So 5.362, and that was a really good number, really close. And then we multiply that by 74.75, which I believe was our X bar. And I'm just taking a look just to make sure I copied it down correctly. Okay, and we'll hit enter. And okay, so negative 175.56 is what we got the second time as well. All right, so that means that our least squares equation is going to be 5.362 x, right, and then minus 175.56. Okay, so, and of course we could check that using our calculator. There's a little bit of variance due to rounding, etc. So not that big of a deal. All right, so last two parts that we're going to do just in this small video, and then we're going to do the residuals in the next video, is we're going to use the equation to predict the height given that the weight is 230. Now weight is the response variable, all right, which is really the y variable. So we're going to plug 230 in for y. And so we're going to get 230 is going to be equal to 5.362x minus 175.56. And to solve this, just like a regular linear equation, we're going to add the 175.56 to both sides. So ultimately, that's going to give us 405.56. Okay. And if you don't trust me, of course, you just go into your calculator and you can add the 230 plus the 175.56, and that gives you 405.56. So just making sure everybody knows where I got that from. And then finally, we're just going to divide by 5.362 to get rid of the coefficient. And this is going to tell us what the height is. All right, so we're just going to go into our calculator, and we're going to take 405.56, and we're going to divide that by the 5.362, I think it was. And we're just going to hit enter. And that gives us 7564 approximately. Right? So, and that's in inches. Okay. So what that means is that if the weight is 230 pounds, we predict a height of 75.64 inches. All right, so now what does that mean to us? So is it an interpolation or is it an extrapolation? So let's go back up, and we have the number 230. And if we were to write the data in order, in fact, let's just go ahead and do that. Let's write these ordered pairs in order down here. So this could be for part E. So we have 71 and 206. And then we have 75 and 214, 76 and 225. And then finally 77 and 244. Now clearly 230 is between two of the original values. And if we were to make a table out of this, just to make sure, this is our X data and this is our Y data, right? And Y is equal to 230, which is clearly between 225 and 244. So this would be an interpolation. And even if you look at the X value is between two values that exist as well, not those two. But it's between here. So both the X and the Y values fall between two existing X and Y values. So it's an interpolation. And we're going to say it's an interpolation since Y equals 230 falls between two original data points. And just to be clear, I'll name them 225 and 244. All right, so that takes care of everything except for the residual. And I'm going to take care of the residual in another video where we go through, we compute the residuals, we identify the point closest and furthest, make a residual plot, and then based on the plot, determine if there's outliers.